guys, welcome to our tutorial. For this video, we will discuss about the overview of heat transfer in thermodynamics. So let's proceed. An overview of heat transfer. Problem number 1. An ideal diesel cycle with air as the working fluid has a compression ratio of 18 and a cut-off ratio of 2. At the beginning of the compression process, the working fluid is at 14.7 PSA and 80 degrees Fahrenheit and 117 cubic inch. Utilizing the cold air standard assumptions, determine the temperature and pressure of air at the end of each process. So in this problem, we are asked to determine the temperature and also the pressure of air at the end of each process. So we have given her here which are compression ratio at 18 and a cut-off ratio of 2. Also we have here a working fluid which is 14.7. We have temperature which is 80 degrees Fahrenheit, and also for volume we have 117 cubic inch. Now let us proceed to our solution. So first, the formula that we will be using here is V sub 2 equals V sub 1 over R. So in this problem, we were looking for V2. So the V1, we have 117 cubic inch divided by 18, which is our compression ratio. So the answer will be 6.5 cubic inch. So we have now the value of our V2. So in solving our V3, we will be using the formula RC for the compression ratio multiplied to V2, which is 6.5. So let us plug all the given. So for RC, or compression ratio, we have 2 multiplied to our V2, which is 6.5 cubic inch. So by multiplying it, we have now our value of V3, which is 13 cubic inch. So now let us find the V4. So for our V4, we will be using, so V4 here is a given. So V4, we have a 117 cubic inch. So let's proceed to process 1 to 2 in finding the isentropic compression. So the formula that we will be using here is the T sub 2 equals T sub 1 multiplied to V sub 1 over V sub 2 K raised to K minus 1. So here, an ideal diesel cycle is considered. The temperature and pressure at the end of each process, the network output, the thermal efficiency, and the mean effective pressure are to be determined. So let us find the value of our T2. So for T2, let us multiply 540 R to 18 raised to 1.4 minus 1. So our 1.4 here is the K minus subtracted to 1. So we have the value of 1716 R. Now let's solve for P2. So the formula that we will be using here is P2 multiplied to V1 raised to V sub 2 raised to K. So equals 14.7 PSI multiplied to 18 raised to 1.4. So 1.4 is may have corresponding value of K. So 1.4. So by solving it in our calculator, we have now the value of our P2, which is 841. So let's proceed. In process 2 to 3, which is a constant pressure, T3 equals P2 equals for 841 PCA. So here we have P sub 2 multiplied to V sub 2 over T sub 2 equals P3 V sub 3 over T3. So let us derive the equation T3 equals T2 V3 over P2. So let us multiply the 1716 R to 2. So we have now the value of our T3, which is 3432. So let us now proceed in solving the process 3 to 4. Isentropic compression expansion. So let us first solve for T4. T4 equals T sub 3 multiplied to V sub 3 over V sub 4 raised to K minus 1 equals, we have 3432R, which comes from the value of T3, multiplied to V3, which is 13 cubic inch over 117 cubic inch. So 100 cubic inch is given in the problem. So by raise to K, which is 1.4 minus 1. So by solving it and putting it in our calculator, we have now the value of our T4, which is 1425 R. Let's proceed. In solving P4, the formula that we will be using here is P3 multiplied to V sub 3 raised to V sub 4 raised to K minus 1. So let us substitute all the given. So for P3, we have 841 PCA over, I raised multiplied to 13 cubic inch over 117 cubic inch, so raised to 1.4. So let's solve for it. We have P4 is equals to 38.8 PCA. So this is now the end of our tutorial. Thank you for listening and God bless us all.